Hello, my name is Ben. I'm going to be showing you how to do a straight line approximation um, given a transfer function, in this case just the magnitude graph. Uh, so as I said, in this case we've been given the transfer function, not a very complicated one, but enough to show the process. So the first thing we want to do when we have a problem like this is find the zeros. So in this case, they're not too complicated to find. They're going to be -13 and -87 for both parts of the denominator. So for this specific purpose, we're going to be using the absolute value of those, and then we're going to look for s values around there. So to start with, I'm going to create intervals around each of these zeros. So we're going to start with uh, s is s is less than 13. And we're going to do 13 is less than s. Uh, so from 13 to 87. And then we're going to do greater than 87. Maybe. Okay, there we go. So we've got three intervals now. All right, so to start with, we're going to just rewrite the transfer function down here. S plus 13, s plus 87. All of that is under 13. Okay, and then for these, I'm just going to copy that down for each of them. Okay, there we go. So we'll start with the first interval where s is less than 13. So the way we're going to solve this is we're going to just pick any value that is less than 13. It can be 1, it can be 0.001. In this case, it doesn't matter. I'm going to use 1. But again, use whatever you'd like. And what we'll do is we're going to compare these two values on the bottom. Anywhere there's an s is where you'll compare it. So you're going to sub this in, you're going to sub the 1 in for s, and you're going to just look at 1 or 13, and you're going to look for which one's greater. So in this case, 13 is greater, so we're going to cross the s out. Same thing over here, we're going to do 1 or 87, and in this case 87 is also greater, so we're going to cross the s out there. Okay, so now that we've crossed both of those out, we're going to carry this over. So the next part is to use, actually I'll write this as a fraction first. So we're going to do 13 times 87, which is 1131. 13. Okay. So for these problems, I'm going to write the equation that we'll use on the right here. It's going to be 20 log of the numerator, and I'm just abbreviating numerator, minus 20 log of the denominator. Okay. And so we're going to plug this equation on the left that we have into that. And so we're going to get 20 log of 13 minus 20 log of 1131. Okay. 13, and that is going to give us negative 38.79. Okay. And one thing to note, so as you're stepping through these problems, what you're approximating, okay, and what that number is the approximate value for this graph in that interval. So in this case, it's going to be less than 13. So I already have 13 and 87 marked on the graph. Remember, it is a logarithmic graph, so it does work a little bit differently. So in this case, that value, so we can see from the interval that is 13 all the way to the left, you can see that's about 38, 39. So that value that we got here does seem to be correct. Okay, so with that, we're going to step on to the next one here. Okay, so now we're looking for a value between 13 and 87. Same thing as the first one, just pick any number. I'm going to pick 50. So we're going to compare 50 or 13. In this case, 50 is larger, so we'll cross that out. Same thing here, 50 or 87, and in this case, 87 is larger. So now we have 13 over 87s. Okay, and so for this one, we're going to do the same process. We will use that same equation, except one thing is going to change. So I'm going to write that out. 20, whoop, there we go, of 13 minus 20 of 87. So now once you get to this point, your S is going to be subbed out for a W. There we go. Okay. And that won't have any effects on the calculations. Because the last step for this, any equations where an S is left over, is you'll make a table. So in this case, I'm going to, there we go, we'll put W on one side. And so what you're going to do is, if you look in between that interval, between the 13 to 87 interval, notice how the graph changes, right? It's not one consistent value. With the previous one, we could assume one consistent value for that whole level because it's flat there. But in this case, we've got two changing, a different start and end of that interval. And so what we're going to do is pick two numbers, or three, or however many, to approximate a line along there. With this graph, it's easiest to use decades, so I'm going to use 10 and 100. So we'll plug those in real quick. So we'll do 10, and that's going to give us negative 36.51, and then we'll do 100, and that's going to give us negative 56.51. Okay, and same thing here. If you look at 10, negative 36.51 is probably around there. The other one, the previous number was negative 38.79. We can put that one on the graph as well. It's a little bit lower. And then the second value that we got was negative 56.51. So I will put that on table as well. And that one is a little bit higher too. Okay. And no worries if it's off. Notice how the lines, or the points right now, are a little bit off on the graph. It's a straight line approximation, so it's not meant to be an exact fit to the graph. Okay, and we'll do the same thing for the last one here. This time it's greater than 87, so I'm going to use, I'll use 100, because that's easy. And it's 100 or 13, in this case 100, and 100 or 87, and that's also 100. And so what we'll get is 13 over s squared. And if the s is squared, no worries with that. You'll do the same thing as the previous one, where you just move that into a w in the equation. And if it's squared, the square comes with it. So it's going to be 20 log of 13 minus 20 log of w squared. Okay. And we'll do the same thing as we did before. We're going to do a small table. So anytime w is left over, you'll make a table, or s is left over. In this case, I am going to use the values of 100 and 1,000. So we'll plug those in real quick. So 100 and 1,000. So 100 is going to give me negative 57.72, and 1,000 is going to give me negative 97.72. Okay. So now at those points, I'm also going to add those to the graph. So at 100, where we've got 57.72, which is going to be a little bit closer to that 60 mark, and then negative 97 there, which is also fairly close. Okay, so now that we have all of those values, let's go ahead and draw the lines. So in this case, it was 38. Yeah, so I'm going to draw a line from there. There we go, and yeah, not quite a perfect fit, but pretty close. And then I'm going to label this as well, 38.79. It's important to note that this graph is in dB. So any of your magnitude graphs will be in decibels. And then negative 36 to 56. So that's going to be from this point to here. Negative 36.51, negative 56.51. Okay, and then these last two values, we only had two, so we'll just draw a line all the way to the end that connects the two of them. Okay, and then this value is negative 97.72, and this one was negative 57.72. Okay, and so you can see they're not quite perfectly overlapping, so I'm going to cross that line a little more. Same thing with this one. We'll draw that one out a little bit more. There we go. What we can do from here is just scribble those overlays out. Yeah, and the overlaps it's okay if they overlap. But yeah, there you go. That's how you find the straight line approximation for the magnitude graph of a transfer function.